Now comes the world of pain, SSL support. This is actually not too horrible usually, but I chose to go with the free Let's Encrypt option. That might have been a mistake in retrospect. In the IDE on our development machine, let's open application.properties and set several important variables. Notice that I will need to comment out these values when running locally, since I can't get SSL when running locally. The server must use SSL for everything, as iOS won't allow regular HTTP connections. To do this, I'll define the server port to 8443 and require SSL. The next few lines point at the key store file, password, and alias. We'll configure all of these values soon. I'll need to redeploy the updated server with SSL setting by copying it to the server. And obviously I'll need to do this line again to move the uploaded file to replace the existing backend server. First, we need to set up DNS for the server. Assuming you already registered a domain, setting the A record to point at the IP address of your server gives it a name. You can't apply HTTPS to an IP address, and it's not a good idea in the long run as it might pose a problem with scaling or migrating. Let's for a second stop and explain how HTTPS works. The server sends a certificate which verifies the identity of the server. For example, this is build.magimob.com, and to prove that certificate is signed by a signing authority. This signing authority is a company we trust to verify that identity. In the past, signing authorities literally looked you up through DUNS numbers, which is a horrible thing I don't want to go into right now. That way they could verify your identity. Let's Encrypt was formed to allow everyone to get a valid SSL certificate for free. It does that by automating the process completely, and the trick is composed of two pieces. The first is an application you run on your server to verify that this is the right server. The second trick is the short lifetime of a certificate, only 90 days. Even if an exploit exists, it will expire in 90 days naturally. Normally certificates last a year or two, and it's really painful to replace them. The 90-day time is horribly short, and the reason it's so short is so we would be forced to automate the process completely. That means our server should request a new certificate on its own without any action from us. That's actually pretty cool. It would mean the certificate will always be renewed and current without any work from us once we do the actual work. One caveat for Java developers is this. In order to recognize a certificate authority, the root certificate should be embedded into browsers and the JDK itself. Most devices, browsers, etc. already recognize Let's Encrypt, but the JDK only added it in update 8U101, which is pretty late in the game. That might mean you will need to update your JDK to access the secure site. So let's get this off the bat. I really regretted picking Let's Encrypt as I walked through the process. It sucks on Spring Boot. The automation doesn't work out of the box, and I needed to do so much wizardry. It's amazing. I don't understand why the guys at Spring or Tomcat didn't implement built-in support for this out of the box. I hope they will add it in an update, but I haven't seen anything so far. I seriously hope the rest of this module becomes out of date. We start by installing some packages required by Let's Encrypt. This is pretty much the instructions you can find online to do that. This isn't a smooth experience, in part because of the newness of Let's Encrypt. The first thing we install isn't so much a thing as it is a third-party repository to look in for additional packages. Next, we install some utilities that allow us to use the config manager in the next step. I honestly have no idea why the hell this is needed, but it's part of the setup instructions, so I went along with it. The certbot is a command line tool that allows us to renew certificates automatically. Certificate robot. Got it? We need to stop the server if it's running. The reason for this is clear when we understand how Let's Encrypt works. It can integrate with some servers, but not with Spring Boot. So the alternative is to let it spin its own server on port 443, which we would normally need. So we need to shut down the server while we renew the certificate. Now that the server is off, we can launch the certbot command, which fetches a certificate from Let's Encrypt service automatically. The command includes several arguments, so let's review the important ones. --standalone means we'll be using the standalone server and can't use integrations to one of the existing supported servers. -d passes the domain name that we want the certificate for, which needs to be the same one associated with the DNS from before. The next two arguments represent the actual ports used for the servers. Notice that port 8 and 443 will be used internally, but since we redirect those to different local ports with the IP table settings, we need to indicate the real local ports to use. Running this one command should generate the certificate, but it doesn't end there. This is another big obtuse command. Let's Encrypt generates a certificate and saves it using a PEM format, which we can't use from Java. We can use this OpenSSL command to convert the PEM file saved in the /etc/Let's Encrypt directory to the key store format we need. We ran that command as root, so I'm using the changeown or chown command to change the ownership of the file from root to builder. This is generally good practice for files within the user directory. It would have probably been a better idea to just run the OpenSSL command as builder. Now that this is done, I can relaunch the backend server and HTTPS should work as expected, but there is still one thing missing.